Hey guys, hope you're having a good day so far. This video is about translations, not to be confused with the word transformations. It sounds similar, but it has a different meaning. So translations is just another name for sliding an object from one place to a new location. You can see from this little picture here that the shape does not change at all. It is not facing a different way. It's not reflected or spun around. It's just sliding into a new location. Okay, so in your notebook, I would jot down the word translations, but I would also jot down the word slide because that's a little bit easier to remember. When you see the word translations, you know we're either moving a figure left or right, that's in the X direction this way, or up and down, which is in our Y direction like this. So we are just kind of relocating our figures. Go ahead and jot down example 1 right here. So translate triangle ABC 4 units right and 3 units up. So we've been talking about this word notation, which if you don't remember, it just stands for like the symbols or the shorthand of what we're trying to explain. So in math, we don't typically, mathematicians won't write out the entire sentence of what they're trying to say. We use symbols a lot. So this notation here kind of summarizes the directions. So translate stands for the capital T, and then 4 units right. This is our movement in the X direction. So I'm going to put X movement, and then 3 units up. This is the movement in our Y direction. So I'm going to put Y movement. And an easy way to remember this is when you write your ordered pairs, you always put the X coordinate first and then the Y coordinate. And it works very similar with this notation. So the X movement goes first, then the Y movement, but instead of parentheses to indicate a coordinate, like a point, we're going to put these little pointy symbols, which stand for something called a vector, and we'll talk about that a little bit in a moment. So this is translate, and then this right here is our vector. Well, we should clarify. This is our X movement, this is our Y movement, and the whole thing is called a vector. Just like our reflections, inside the parentheses is our pre-image. And then after the equal sign is our result, our image. And we always want to put the prime symbols onto our image. So if you're not quite sure, you might remember that. Put a little note to self. Prime symbols are important on our image. Okay, so go ahead and copy down the coordinates for this first example. So we've got triangle ABC. I gave you the coordinates. A is at 0, 0. B is at -7, -5. And C is at -2, -8. So the first thing you'd want to do is graph the pre-image. And then we're going to use our vector, that's this right here, to decide where we're going to place our image. And so the easiest way to do this is to take each point and just move it according to the directions. So 4 units to the right, that would bring me to an X value of 4. And 3 units up, that would bring me to a Y value of 3. So essentially I just added 4 and added 3. I'm going to do the same thing for my coordinates of B. So -7 plus 4 is going to bring me to -3. -5 plus my Y movement of 3 up, so add 3 would be at -2. Again, last one, so -2, adding 4 for my X value would bring me to a +2, and then -8, add 3 for my Y value, I would be at -5. So now we're going to graph our image, and I would always recommend that you do this in a different color so that you can clearly see the difference. So A is going to be 1, 2, 3, 4, 1, 2, 3. Label that A prime. B is at -3, -2. and C is at positive 2, negative 5. 1, 2, 3, 4, 5. When you label those points, you want to make sure that they have the prime symbol. And then I just grab like any straight edge that you have lying around. I'm going to use the edge of this little thing here. And there we go. So now if we compare our pre-image to our image, we should see that they're just like the little smiley face at the beginning of this video. The shape should not have changed at all. It should be still facing the same way because all we've done is slide this figure. One more really important thing that you want to jot down into your notes, and we'll revisit this, is that vectors have something called a magnitude and a direction. So we probably know what the word direction means. It just kind of tells us which way we're moving this shape. And a magnitude tells us the extent, like how much are we moving this figure. And the direction would be like where are we moving this figure? Left, right, up, down, etc. All right, example 2 says write in words and draw. So we need to figure out what this notation is telling us. So capital T means translate. What are we translating? Triangle ABC. Translate triangle ABC. And now we want to explain what that vector is telling us. So if there's a negative 6 in the first part of my vector, remember that is like the X movement. So that means if it's negative 6, we'd be going 6 to the left. So translate triangle ABC, 6 units left. And for my Y movement, there's a positive 2. So 2 units. If it's positive, that means we're going to the right. Oh, whoops. It's supposed to go here. So that's how you would write that out in words. So I gave you the coordinates A, B, and C. See if you can plot them and then figure out where the coordinates for our image would be, and then you can resume the video and see if you got it correct. Okay, so here's where our pre-image started, and you can see the coordinates that I've recorded over here by subtracting 6 from each of my X coordinates and then adding 2 to each of my Y coordinates. And so this is what my final image would look like in the red here. So just to give you an idea of what a vector really looks like, I'm going to connect my image to my pre-image to my image. So I'm just going to use point B. So from B to B prime, outline this in pen here, this arrow looking thing here would be something called a vector, and that shows us the direction that our image is moving to and then also how much we're moving it. So this would be a vector. Example 3 says find the coordinates of point A if this little symbol here stands for vector. So if the vector is 7, negative 2, if that vector was used to translate it to the image point of 1, 4. So this is an interesting question because now we are given the image and we are asked to find the pre-image. So the pre-image, which is A, we don't know, but we know that the image after this vector, A prime, is 1, 4. So we need to work our way backwards. So if we started with a point and then we moved it 7 units right and it brought us to a positive 1, if I do the opposite, that will bring us back to the pre-image. So if my image ends here, if I subtract 7, that will give me the x value. So that would be -6. And likewise, if I do the opposite for my y movement. So whatever I started with, I moved it 2 units down and it brought me to the y value of 4. So if I go 2 units back up, that will give me my original y value, which would be 6. You can always check this, because if I have the coordinates -6, +6, and I use this vector, right? So here's my vector, 7, -2. Just like we did in the last example, if I just add 7 to my x coordinate, that would give me a +1. If I subtract 2 from my y coordinate, that would give me a +4, which is the result. That's A prime. So that's how I know I did it correctly. So my final answer would be -6, 6. That's where this point started. Example 4 has 4 parts. All of them, you're just going to find the image point. So they are giving you individual coordinates. So part A says, translate the coordinate 7, -2 by a vector of 3, 5. So 3 units right and 5 units up. So that means I'm going to add 3 to my x, and I'm going to add 5 to my y. So my image is going to be at the point 10, 3. B is very similar. It says translate the point 8, 11 using the vector -1, 0. So all this is telling me is 1 unit left. Because there's a 0 for the y part, I'm not going up or down. So my y coordinate is not changing at all. I'm only moving 1 unit to the left. So you can picture this, you can draw a little sketch if you want, or you can follow the same type of pattern up here. 1 unit left means I'm going to subtract 1 from my x. So that would be 7. 8 minus 1 is 7. And then 11, it's not moving at all, so it's still at 11. Okay, what I want you to do now is go ahead and fill in these last 2 answers. I'm going to ask you to check these with a neighbor when we come back into class the next day. So you want to have something prepared to show me that you've watched this, that you understand this, or if you have a question, you can ask a question. Once again, just a quick little reminder that vectors have a magnitude and a direction. So what we're about to do now is figure out how to calculate the exact magnitude when you're given a vector, instead of just saying, oh yeah, it's moving by that much. We want to find out the exact value. So this example actually does not have the translation notation, because this one is just about vectors. So example 5 says a vector has an initial point at I, -2, 2. So I'm going to plot that. -2, 2. I would be here. That's the initial point. That means like start point. And a terminal point at t, which is at 2, -1. So terminal point is like end. Initial is like start. So I'm going to plot my endpoint 2, -1. That's important to indicate the start and the end, because that tells us the direction that the vector is going, from I to t or t to I. So since I is my start and t is my end, my vector is going in this direction from I to t. Okay, so you want to go ahead and draw that vector if you haven't already. If you don't have the little paper, you can just plot an x and y axis and draw your vector by connecting the 2 points. So you can draw a little sketch. So that's what it would look like. To write the vector in component form, this is just another way of explaining the notation that we've been using with the little brackets, where A represents like our X movement and B represents our Y movement. So if I look at the movement from I to T, right? So the X coordinate starts at -2 and it ends up at +2. So the total movement there would be 1, 2, 3, 4 units. So my X movement is 4. And then we want to also figure out what our Y movement would be. So my Y movement is going 1, 2, 3 down. Another way you can figure that out without the picture would be 2 to -1. Well, I would need to subtract 3 from 2 to get me to -1. So -3. So this would be writing out the vector in component form notation. C says find the magnitude. So I want to figure out, again, basically like the length of this vector. So you need to think way back. How do we find the length between any 2 points? There's 2 ways that you could do this. So some of you might be looking at the picture saying like, oh, that looks like a little right triangle. I remember doing, you know, a squared plus b squared equals c squared. The 3, the 4, those would be my legs. The vector would be my hypotenuse. If that popped into your mind, that's definitely a method you could use. So 4 squared plus 3 squared. Or you might know the 3, 4, 5 triangle. So this is the square root of 25, which we know is, 5. So 5 is my magnitude. That's one method. If that did not pop into your head, if you did not think about the Pythagorean theorem, you didn't even see that little right triangle, you could always do the distance formula. So the distance formula, just to rack your brain, x2 minus x1 squared plus y2 minus y1 squared. And you would plug in the coordinates for I and t into our distance formula. And if you go ahead and solve that, you should end up with the same magnitude of 5. You can pick whichever method you prefer when finding the magnitude, but you do need to know one of the 2 methods. Okay, so hopefully this video helped you out with a little bit of translations and vectors. Just a little reminder before you hang up this video that these 2 questions you're going to bring into class so we can talk about it and lead into a little discussion. All right, have a great day.